Section 6.6, Solving Equations by Factoring. In an earlier chapter, we discussed how to solve a linear equation. For example, linear is ax plus b equals 0, and so we had maybe 3x plus 5 equals 0. And we learned how to solve that. If we had 3x plus 5 equals 0, we learned that we could subtract 5 from both sides and divide both sides by 3, and x was negative 5/3. Now, if we had a quadratic equation, so now a quadratic equation is an equation that fits the form ax squared plus bx plus c equals 0. And so it might look like 2x squared plus 7x plus 3 equals 0. And if we have an equation like this, the steps that we learned for a linear equation don't work here, okay? So we have to learn a new method. So the first thing we need is this property. There's a property of mathematics, of algebra. It says that for any real numbers a and b, if a times b equals 0, then a equals 0 or b equals 0 or both. All this is saying is that if you multiply two things and you get 0, then one or both of them must have been 0. And if you think about how multiplication with 0 works, this property should make sense. Now, what's very important is it must be 0. It can't be any other number. So if we had x times x plus 10 equals 0, I have a product of numbers equal to 0, then x equals 0 or x plus 10 equals 0. Now we're asked to solve. So I want to find the values of the variable. I need to find the values of x. X equals 0. Okay, that's fine. X plus 10 equals 0. Let me subtract 10 from both sides. And x would equal negative 10. Alright, so we have two solutions, and we might just write something like, you might write x equals 0, comma, x equals negative 10, or you could write the solution set containing 0 and negative 10. Alright, so now, why don't you pause and try to solve these equations. Alright, so if I have y plus 4 times y minus 7 equals 0, I have a product of numbers equal to 0, then the first number equals 0 or the second number equals 0. Alright, so now if y plus 4 equals 0, then subtracting 4, y would equal negative 4. If y minus 7 equals 0, then adding 7, y would equal 7. So the solution set would be negative 4 and 7. Now let's check this real quick. This one's easy enough to check. If y equals negative 4, then you'd have 0 times negative 11 equals 0. Well, that makes sense. And if y equals 7, you would have 11 by 0 equals 0, and that makes sense as well. So these are really easy to check. So now, if you had 6n plus 5 by n minus 2 equals 0, then you have a product of numbers equal to 0. So 6n plus 5 equals 0, or n minus 2 equals 0. Alright, so if 6n plus 5 equals 0, we would subtract 5. And 6n equals negative 5. And dividing by 6. n equals negative 5/6. And if n minus 2 equals 0, then adding 2, n equals 2. So the solution set would contain negative 5/6 and 2. So now how do we solve a polynomial equation? I mean, if we wanted to solve 2x squared plus 4x equals 0, how would we solve it? The first thing we do, well, is get it equal to 0. It already has one side equal to 0. So now what we're going to do is factor the polynomial. 2x squared plus 4x is the same as 2x times x plus 2. So we now have 2x times x plus 2 equals 0. Now I have it as a product equal to 0. So then 2x equals 0 or x plus 2 equals 0. Now if 2x equals 0, well, dividing by 2, x would equal 0. If x plus 2 equals 0, subtracting 2, x would equal negative 2. So there are two solutions to the equation, 0 and negative 2. All right, why don't you try the next one on your own? Solve the equation. 6z squared minus 3z equals 0. Well, again, let's see, common factor is 3z, so I would write this as 3z by 2z minus 1 is equal to 0. I have a product of numbers equal to 0, then 3z is 0, or 2z minus 1 is 0. If 3z is 0, dividing by 3, z is 0. If 2z minus 1 equals 0, adding 1 to both sides, we'd have 2z equals 1, and dividing by 2, z is a half. And so the solution set contains 0 and 1/2. All right, now let's say we had x squared minus 2x minus 3 equals 0. Well, lead coefficient is 1, so I know I can write that as a factored form using the techniques I learned about in the first factoring trinomials section. So is there a pair of numbers that multiplies to negative 3 and adds to negative 2? Pair of numbers that does that. Let's see, 1 and 3, and getting the signs right, positive 1 and negative 3. So then this can be factored as x plus 1 by x minus 3, and so x plus 1 times x minus 3 equals 0. Now using our property, x plus 1 is 0, or x minus 3 is 0. Subtracting 1 from both sides on the first equation. We have x equals negative 1. Adding 3 to both sides on the second equation, we would have x equals 3. So the solution set contains the solutions negative 1 and 3. Why don't you try the next one on your own? All right, x squared minus x minus 20 equals 0. No common factor there, and the lead coefficient is 1. So let's find a pair of numbers that multiplies to negative 20 and adds to negative 1. 4 and 5 is the pair that I want here. And let's see, a positive 4 and a negative 5. So then I would write this as x plus 4 by x minus 5 equals 0. So then x plus 4 is 0, or x minus 5 equals 0. So subtracting 4 from both sides on the first equation, I'd have x is negative 4. Adding 5 on both sides of this, we would have x equals 5. And so the solution set would contain the numbers negative 4 and 5. All right, what if we had 4y squared minus 25y minus 21 equals 0? All right, so now the lead coefficient is not 1. We have to be more careful. This is the more difficult situation. 4 times 21, 4 times negative 21 is negative 84. We need a pair of numbers that multiplies to negative 84 and adds to negative 25. All right, so let's see. Let's find that pair of numbers. 1 and 84, 2 and 42, 3 and 28. 3 and 28 will work. I need a positive 3 and a negative 28. So I would have 4y squared plus 3y minus 28y minus 21 is 0. Grouping, I'd have y by 4y plus 3 minus 7 by 4y plus 3. And so that would factor completely as 4y plus 3 by y minus 7. And that's still equal to 0. So then 4y plus 3 equals 0. Or y minus 7 equals 0. Alright, so on the first equation, 4y plus 3 equals 0, I would subtract 3 and divide by 4. Y equals negative 3/4. The second equation, I would simply add 7 and y equals 7. Alright, why don't you try the next one out on your own? Alright, 6y squared plus 19y plus 10 equals 0. No common factor. So let's see, 6 by 10 is 60. I need a pair of numbers that multiplies to 60 and adds to 19. 1 and 60, 2 and 30, 3 and 20. 4 and 15. That's the pair that I want. Both positive would give me a sum of 19. So I'd have 6y squared plus 4y plus 15y plus 10 is 0. I'm no longer going to do the coloring here on the factoring by grouping. So let's see, I'd have 2y by 3y plus 2 plus 5 by 3y plus 2 is 0. So that's 3y plus 2 by 2y plus 5 is 0. So then 3y plus 2 is 0, or 2y plus 5 equals 0. For 3y plus 2 equals 0, subtracting the 2, dividing by 3, y equals negative 2/3. And for 2y plus 5 equals 0, subtracting the 5, dividing by 2, y equals negative 5/2. So the solution set contains negative 2/3 and negative 5/2. All right, let's say we had to solve the equation x squared minus 81 equals 0. This one is fortunately somewhat easier. Remember, that's that difference of squares idea. And so this could be factored as x plus 9 by x minus 9 is 0. So then x plus 9 equals 0, or x minus 9 equals 0. If x plus 9 equals 0, subtracting 9, x is negative 9. If x minus 9 equals 0, adding 9, x is positive 9. Alright, and why don't you try this next one out on your own. Alright, 4m squared minus 9 equals 0. Again, that's a difference of squares. It can be factored as 2m plus 3 by 2m minus 3 equals 0. So then, 2m plus 3 is 0, or 2m minus 3 is 0. And for the first equation, let's subtract 3 and divide by 2. And for the second equation, add 3 and divide by 2. So the solution set contains negative 3/2 and positive 3/2. Alright, so now a couple of more general equations. Here we have 2x squared plus 3x equals 14. So now notice in all of the previous equations, the one side of the equation was always a 0, and it must be a 0 to apply that property. So all I will do here is subtract 14 from both sides. And that gives me equivalently 2x squared plus 3x minus 14 is 0. Alright, so now, since I have a 2x squared, I'll multiply the 2 and the negative 14. And that gives me a negative 28. So I need a pair of numbers that multiplies to negative 28 and adds to 3. And let's see, 1 and 28, 4 and 2 and 14, 4 and 7. 4 and 7 is the pair that I want. A negative 4 and a positive 7. So that would become 2x squared minus 4x plus 7x minus 14 equals 0. So that would become 2x by x minus 2 plus 7 by x minus 2 is 0. And so we'd have x minus 2 by 2x plus 7 equals 0. And so we'd have x minus 2 equals 0, which implies that x equals 2. Or 2x plus 7 is 0, which implies that x is negative 7/2. So the solution set would contain 2 and negative 7/2. Alright, and why don't you try this next one on your own? T times t minus 7 equals negative 12. Alright. So the first thing I would do here is try to get this to a more standard form. So let me distribute. T times t minus 7 is t squared minus 7t, and that's negative 12. Now, let me get it to the one side equals 0 by adding 12 to both sides. So I'd have t squared minus 7t plus 12 equals 0. Now this is the simpler case for factoring, and since the lead coefficient is 1, so I just need a pair of numbers that multiplies to 12 and adds to negative 7. Let's see, we have 1 and 12, 2 and 6, 3 and 4. 3 and 4 is the pair that I want, and if they're both negative, then I'm good. So that would become t minus 3 by t minus 4 is 0. So t minus 3 equals 0, which implies that t is 3. T minus 4 equals 0, which implies that t equals 4. So we have 3 and 4 as the solutions. Alright, and we'll finish off this section with a couple applications. First one asks us to use the Pythagorean theorem to find the value of x in the figure. Alright, so applying the Pythagorean theorem, we would have that x squared plus x plus 7 square is equal to x plus 8 square. Alright, multiplying everything out, we would have x squared. Now remember, x plus 7 square follows that pattern that was shown somewhere in Chapter 5. Or you could write it as x plus 7 times x plus 7, FOIL and combine like terms. You'll get an x squared plus 14x plus 49. X plus 8 squared, similarly, is x squared plus 16x plus 64. Simplifying the left-hand side, we have 2x squared plus 14x plus 49 is x squared plus 16x plus 64. Alright, now I'm going to get this to a standard form, to get the one side to 0, I'm going to subtract everything from the right. I'll do the same on the left. And so then that would give me 2x squared, 2x squared minus x squared is simply x squared, minus 2x minus 15 is 0. So we need to now solve that equation. So I'm just rewriting it here. Alright, so this is the simpler trinomial case, and so we just need a pair of numbers that multiplies to negative 15 and adds to negative 2. And so I know I'd have a 3 and a 5. And it would be a plus 3 and a minus 5. So then x plus 3 is 0, which implies that x is negative 3. Or x minus 5 equals 0, which implies that x equals 5. Alright, now we look at this and say, should we accept both of the solutions? Well, remember now, x is the side of a triangle. So, can negative 3 be the length of the side of a triangle? Not right now. So we would reject the negative 3 and accept the x equals 5. Alright, so suppose the height h in feet of a baseball after t seconds is given by the formula h equals negative 16t squared plus 88t plus 3. At what values of t is the height of the baseball 75 feet? So we want to solve for t. At what values of t? So solve for t. Is the height 75 feet when h is 75? Alright, so substituting, we would have 75 is negative 16t squared plus 88t plus 3. Well, let me get the one side to 0 by subtracting 75 from both sides. So that would give me 0 is equal to negative 16t squared plus 88t minus 72. Alright, now, I have an equation. I have a polynomial equal to 0. So let's do some factoring. So 0 would equal, oh, now wait a second, is there a common factor? So remember, if there's a common factor, you want to factor that out first. Well, it looks like 8 would work. 8 goes into 16, 88, and 72. And since the lead coefficient is negative, I'm going to factor out a negative 8. So I'd have negative 8 by 2t squared minus 11t plus 9. Alright, now focusing on the trinomial that remains, 2 by 9 is 18. So we need a pair of numbers that multiplies to 18 and adds to negative 11. The pairs of numbers that multiply to 18 are 1 and 18 and 2 and 9. And since we need the same signs, -2 and -9. So I'd have 0 is -8 by 2t squared minus 2t minus 9t plus 9. Factoring by grouping, I'd have 2t by t minus 1 minus 9 by t minus 1, or -8 by t minus 1 by 2t minus 9. So now I have 3 factors being multiplied and giving me 0. So that implies either the first is 0, so -8 equals 0, or the second, t minus 1 equals 0, or the third, 2t minus 9 equals 0. Now -8 can never equal 0, so let's throw that one away. T minus 1 equals 0 when t equals 1. 2t minus 9 equals 0, adding 9 dividing by 2, when t equals 9 over 2. So we have the values of t. And so we would answer, maybe with a nice complete sentence, the ball is 75 feet in the air after 1 second and 9 over 2 seconds.